Okay, in lesson 2 I went over the graphing of polynomial functions. In this lesson I'll be looking at the graph or graphing of rational functions. Now, a rational function has the following form. So here's a definition: f of x equal to n of x over d of x. So basically we have a polynomial over a polynomial where d of x does not equal 0. So basically the domain of the rational function are all real numbers except those that make the denominator 0. The degree of the numerator, polynomial descending powers, is given by the highest exponent here, the first term n. The degree of the denominator is m. So I did a video earlier where I showed how to find the asymptotes, vertical, horizontal, and slant asymptotes or oblique asymptotes of a rational function. So I'll be applying some of those ideas in this video. So let's look at the first example. So sketch the graph of each of the following rational functions. Okay, typically you want to use some key points. X-intercept, if the function has an x-intercept, we want to use that in the graph. A y-intercept, obviously you want to locate your horizontal and any vertical asymptotes the graph might have. So in this particular case then, we want to find the x-intercept. So the x-intercept is obtained by replacing the y by 0. So in this case, the f of x is the y, so put a 0 right here. So I want to know, when is this thing equal to 0? Well, because it's a fraction, it's equal to 0 when the numerator is 0. Well, the numerator will be 0 at 0. So 0, 0 is the x-intercept. Now the y-intercept is obtained by replacing the x by 0. So put a 0 where the x is. I get 0 over negative 9, so the y-intercept is 0, 0. Okay, 0 over negative 9 is 0. So obviously 0, 0 is an x and a y-intercept because it's at the intersection of both the y and the x-axis. Okay. Now the vertical asymptotes basically come from numbers that make the denominator 0. That is where the function is not defined. But those numbers cannot make the numerator 0. So you can see here that the numerator factors into x, or the denominator I should say factors into x minus 3 and x plus 3. So the numbers that make the denominator 0 are 3 and negative 3. So that's why I have x equal to 3 and x equal to negative 3. Those are the vertical asymptotes. So here I have 3 units over, I have one vertical asymptote. 3 units to the left, I have the other one. Okay. For the horizontal asymptote, I look at the degree. Okay, so the degree of the numerator is 1. The degree of the denominator is 2. Looking at the highest degree exponent. Okay, so 1 is less than 2. So what I said earlier then, and I said this in the last video, or in an earlier video, if the degree of the numerator is less than the degree of the denominator, then y equal to 0 is a horizontal asymptote. So in this case, the x-axis is a horizontal asymptote. Okay, now in the video where I went over the graphing of polynomial functions, basically I took the real zeros of the polynomial and plotted them on a number line and determined the sign of the function over each of the intervals formed by those values, and that told me whether the function was above or below the x-axis. So using the key points, also the x and the y-intercept, we were able to sketch the graph. Okay, so in this case what we'll do is I have the zeros of the numerator and the zeros of the denominator. Okay, that's what I'm going to do for the rational function. So I find the zeros of the numerator, which in this case is 0, and the zeros of the denominator, so it's the numbers that make it 0, are negative 3 and 3, and there you have it. So all I'm going to do now is just determine the sign of the function over each interval. That is, to the right of 3, between 0 and 3, between negative 3 and 0, and to the left of negative 3. So I pick a number larger than 3, say 4. So I put a 4 where the x is. 4 here, so it would be 4 squared minus 9 is a positive 7. So I get a positive over positive. So that tells me then that in here, the graph is positive for values larger than 3. You can try any other values and you still get a positive sign. Between 0 and 3, I'll pick a 1. So put a 1 there, a 1 there. You can see that in this case I'm going to get a positive over a negative. That's negative. So in here it's negative. Between negative 3 and 0, I'm going to pick a negative 1. So I put negative 1 there, a negative 1 there. So I'm going to get a negative over a negative. That's a positive. Okay. To the left of negative 3, I'm going to pick negative 4. So put a negative 4 there, negative 4 there squared. So this will be 16 minus 9. That's positive. So I'm going to get a negative over a positive. This will be negative. Okay. So to the left of negative 3, the graph is below the x-axis because I have a negative. Between negative 3 and 0, it's above because it's a positive. Between 0 and 3, it's below because it's negative. And to the right of 3, it's above because it's positive. Okay, so I'll come back to the graph. And again, the only points I'm going to plot in this case will be one point, and that's going to be the origin, because I know the graph passes, okay, to that point right there. So then use your number line as a guide. So I'm going to start on the right of this number line. So I'm saying to the right of 3, it's plus. So here it is. Here's x equal 3 here. To the right, it's plus, so the graph has to be above the x-axis. Okay, common sense then. I have a vertical and a horizontal. So I draw the graph so it approaches both. So this will go something like that. Now, it could be a little bit lower. It could come a little bit lower like this, or it could flatten out a little bit more like this. But it approaches the vertical and the horizontal. Between 0 and 3, it's negative. Okay, so it's going to pass to this point, and between 0 and 3, it's going to be negative, so it has to come down. Okay, so I draw it. So it approaches it, something like that. Between negative 3 and 0, I have a plus, so it's going to go back up. Okay, so here it's going to go something like that, approaching the vertical. Between negative 3, or to the left of negative 3, it's negative, so it's going to be below. So again, I have a horizontal and a vertical, so I draw the graph. So it approaches both. So you get something that looks like that. Now, I mentioned this in the earlier video. A graph may cross a horizontal asymptote or a slant or oblique asymptote. It's never going to cross a vertical asymptote because that's where the function is not defined. So this is an example of one where it crosses the horizontal here, y equals 0. But then over here it never crosses again. Over here, as x goes to negative infinity, it never crosses again. And the reason I know that is because I don't have any more x-intercepts. So that's what your graph is going to look like. Domain of this function obviously is all numbers except 3 and negative 3, because those are the numbers that make the denominator 0. Let's clear this. And go to the next one. So again, the x-intercept is obtained by replacing the y by 0. Okay, so I want to know then when is x minus 4 over x minus 2 equal to 0? Well, it's equal to 0 when the numerator is 0, and the numerator is 0 at 4. So that's why I get the point 4, 0. Okay, y-intercept is obtained by replacing the x by 0. So put a 0 there, 0 there. I get negative 4 over negative 2 is a positive 2. There you have it. Now the vertical asymptote comes from numbers that make the denominator 0, but not the numerator. Well, you can see the denominator again is 0 at 2. So x equal 2 is a vertical. I have it over here. Okay, so over here, going 2 units to the right, this is my vertical asymptote right there. The horizontal asymptote is determined by the degree. In this case, the degree of the numerator and the denominator are the same, 1 and 1. So you take the coefficient on top, lead term, over the lead term in the bottom, 1 over 1, you get y equal to 1. So I go over here in the coordinate system, 1 unit up, and I draw my horizontal asymptote, y equal to 1. Okay, now it's just a matter of putting this together on the number line. So, again, what I do is I plot it on the number line, the zeros of the numerator and the zeros of the denominator. So the numerator was 0 at 4, there's my 4. The denominator was 0 at 2, there's my 2. And then I simply determine the sign of the function on each of the intervals formed by these numbers. So to the right of 4, I put a 5. Put a 5 there. 5 minus 4 is 5 minus 4 is positive. 5 minus 2 is positive. Positive or positive is a positive. So in here, to the right of 4, the graph is above the x-axis. Between 2 and 4, I pick a 3. So 3 minus 4 is negative. 3 minus 2 is positive. So we're getting a negative or a positive. That's a negative. So between 2 and 4 there, the graph is below the x-axis. Okay, to the left of 2, I'm going to pick a 1. So pick 1 minus 4 is a negative, 1 minus 2 is a negative. A negative over a negative is a positive. Okay, you use this number line as your guide. Okay, so this is x equal to here, so we'll go 3, and then this will be, say, 4. So the graph passes at 4, 0. That's an x-intercept. And to the right of 4, I have a positive. So that tells me then that the graph has to pass to that point, but then it's going to go up. And because I have a horizontal asymptote, I draw it so it approaches it. And then because I have a vertical at 2, this is going to come down because the sign over here between 2 and 4 is negative. This has to come down and approach the vertical asymptote x equal 2. Now I know the graph is going to pass through the point 0, 2. So this is 1, so I go 1 more, that'll be 2. That'll be the point 0, 2. And to the left of 2 it's plus. Okay, so here's x equal 2, so to the left it's positive, so the graph has to be above the x-axis. But again, because I have a vertical and horizontal, then the only option I have then is, because it goes something like this, let's go here, pass to that point, and then it's going to go up and not going to cross. So in this particular case, the graph does not cross the horizontal. The previous example was one where the graph crossed the horizontal asymptote at that particular case. In that particular case, it was at the origin. Okay. So this concludes this video. If you have questions or things you want to post, please post them. Any suggestions, and you subscribe, I will consider them. So we'll see you in the next video.